Hi everyone, welcome back to Operations Research. This is our second course. We're talking about algorithms, and today we're going to talk about branch and bound and heuristic algorithms. So we all know that we sometimes face variables that are integer values. Okay, so that may be integer variables where values may be 5, 10, 15, but cannot be fractionals, or that may be binary variables. So in that case, we are doing integer programming. So integer programming is saying that we need to formulate and solve models with integer variables. So in this case, mostly we are talking about linear integer programs. Okay. In fact, we do have some cases with nonlinear integer programs, but that may be too difficult, at least too difficult for this course. So mainly for today, we will only talk about linear integer programs, all right? So our plan is that we're going to talk about two sets of algorithms or two different principles for solving integer programs. The first is the algorithm, which is called the branch and bound algorithm. So branch and bound is an algorithm that finds an optimal solution for a linear integer program. So the thing is that we will show you how this integer program may be solved. Pretty much we are decomposing an integer program to multiple linear programs. We solve all those linear programs and see whether we have a conclusion. Each linear program is solved separately. You may use the simplex method or any other method. We will give you some examples. So we're going to show you all the details, and somehow you will see the process may take such a long time. That is not really acceptable in practice. If you really have a program that is too large with a lot of integer variables, then this may not be a good idea. So if this is too time consuming and you really need a solution as quickly as possible, we may do another way. We look for a near optimal feasible solution, and that may be good enough in practice. Because if you don't have a solution, then the model is useless. If you can have a near optimal solution, that may still be executable and useful in practice. So if we have an algorithm that generates a feasible solution in a short time, and even if that feasible solution is not optimal, it may still be useful. In this case, we say we have a heuristic algorithm, and hopefully that heuristic algorithm generates a solution that is near optimal. So we will show you some concepts about that, some example about that, and how to measure whether a solution is near optimal or not. So it may not always work, but hopefully it works for most of the time. Then it is a reasonable way to tackle integer problems.